Hello everyone. Good evening. Is everyone able to hear me?
Yeah, we can hear.
All right. Thanks, Akhil, for confirming. Okay, I can see in the chat that folks have been saying yes, acknowledging it. So thank you so much, everyone, for acknowledging. Okay. All right. So we can get. So right now it's 4:01. We can get started from 4:05. So before moving, anyone just want to say how is Sunday going for all of you? IPL. Okay. Okay. Awesome. I'm just reading out comments, watching IPL. I see. Yeah. So IPL has got us covered for next couple of weeks. Okay. So says that calm being waiting for this. It's raining here in Indore. Har Harshal said. Okay. By the way, I'm also from MP, so I'm from Satna. Good to know. Good to know you, Harshal. So seems like you're having a pleasant weather over there. Oh, nice, Rohit. Okay, you're from Chitrakoot. I see. So, Ankit, how can I find internship and in DevOps? So, yeah, we'll let you know. So, we have a lot of things which are going to be covered in this session. So, yeah, we'll talk more on that. Yep, definitely, we'll answer it. All right. I think that we can get started. It's around 4:03 right now, but yeah, let's have an early start because I can see that uh, pretty much like a lot of overwhelming responses in the chat. So maybe uh, let's start. So hello everyone, this is Sankalp. I hope everyone is doing great and having an amazing Sunday so far. So welcome to the live stream. So we are Cloud Clan. So I hope uh, everyone is aware of Cloud Clan and what is it? Like anyone just want to type it out in the chat to let us know. Mm-hmm. Okay. So coax in Loth said DevOps community. That's correct. So okay, just let me give a little brief of background about Cloud Clan now. So Cloud Clan is a community that is basically driven by Akshay, Sabir, Prasad, Lakshman, and myself. So we are basically, we basically foster people on the top-notch like tools which are being currently used in the DevOps world. So we have a boot camp where we conduct sessions on these DevOps tools that includes Docker, Kubernetes, Terraform, various cloud providers uh, like Ansible, Helm, Jenkins, and whatnot. So you can, just check us out on our LinkedIn page. You can just, go through the post that we have posted out on the LinkedIn page. Just like it. If you're interested, if you are in the DevOps world, if you're working, either you are just starting out, like there are a lot of things that we do inside uh, like Cloud Clan. So just do check us out and like it to get updates. And yeah, updates on our basically latest workshops and other activities that are being carried out. So that is gist of us. So recently, Cloud Clan has come up with a new series called CI/CD Free Workshops Marathon. So that includes basically a live stream sessions on total of 9 CI/CD tools. So I hope that that must sound pretty like exciting and interesting to all of you. So we are going to cover 9 CI/CD tools. So that includes like GitHub Actions, GitLab CI/CD, Jenkins, a lot. So probably Akshay will be posting out in the chat about the workshops that we are going to like conduct on these CI/CD tool. So yep, okay. I can see a lot of overwhelming responses here. So great community to support DevOps people. So Rashid is saying, okay, all right, all right. So all these, so one quick fact about all these workshops, which we are going to conduct on CI/CD. So they are totally free of cost, and they will be live streamed. And today we are kicking off with our first session on the series that is starting with GitLab CI/CD. So I welcome everyone once again to the session. So we have Akhil, who is a certified GitLab associate and a DevOps engineer at Sentinel Solutions. So throughout his career, he has authored, a numerous production pipelines using GitLab CI/CD, worked on multi-cloud containerization technology and whatnot. So, so Akhil will be leading today's session. So I would request everyone to just focus and try to get things out, the most things out from this session. So in case you have any queries, just feel free to drop in the chat. So I can still like I can see that a lot of you are like posting some questions and having some conversation going in the chat. So just do the same and feel free to drop the questions in the chat, and we have a dedicated Q&A session waiting at the very end. So yeah, with that being said, so like I would like to welcome Akhil, and yeah, thanks Akhil for joining. So I'll hand it over to you, and the virtual podium is all yours now. Over to you.
Thank you, Sankalp. Thank you for having me. So, hey everyone, we're gonna start today's workshop. It's on GitLab CI/CD, and let us begin. Is my audio clear?
Yep, it's perfect. You're perfectly audible.
Okay.
Yeah.
Let me know if my screen is visible. Everyone can see my screen?
Not yet. Yep, it's coming up. Yep, we are able to see your screen.
Okay, great. So, I welcome you all for today's session. It's a CI/CD workshop on GitLab, and I'm Akhil PH. I'm working as a DevOps engineer for Standalone Solution, and I'm also a GitLab certified associate. So, what is CI/CD? I'll give you a brief history first. So even before this practice come into the CI/CD DevOps was in place, there were people still making softwares. There were people making application. But the problem with that was there was a huge delay between releases because they have been following a lot of models before. There's waterfall model, spiral model. all these agile before agile they were having this software development life cycles in place. So the problem with that was there was a huge delay between releases of application, and there was no feedback. So let's say if a guy is creating a software, he's going to work on that continuously, and once he have a build, he's going to deploy that to production or any target environment. And the problem is they will only come to know about any potential bugs or vulnerabilities once the application is deployed. So that was the history. So that's why we have CI/CD in place and the practice of DevOps. So what is CI/CD? So CI/CD is a practice that we do in DevOps, and CI stands for continuous integration. So what this means is, this is a practice of automatically integrating and building your code changes from multiple developers into a shared repository. And this process involves merging your code, building your code, doing automation testing on your code. And the goal of continuous integration is to find or detect potential bugs and vulnerabilities earlier in the development stage, before it's going to hit the target environment or production servers. So with the continuous integration will always ensure that you have an application that always has that always remains in a releasable state. So you're integrating your code. When you're working on an application, there will be multiple guys working on that. So they are going to integrate all those features together, and for that they are going to use Git, which is a code version control system. And from there we can do integration, then building the code. So these will happen like the velocity of what's happening when we are using CI CD is much more faster when compared to what was there previously. So you'll be having multiple releases a day, you'll be doing automation testing. So all this will help you to have a stable application that's always ready to be deployed. That's what continuous integration means. And let's talk about continuous deployment or continuous delivery. So we can coin it as, it's like a coin, it has two faces. So continuous deployment means it's just another extension of CI that involves automatic deployment of already built and tested application to any of your target environment. It will be maybe testing environment, production environment, anything. And the target uh, the deployment target will be maybe VMs or Kubernetes cluster, Nomad cluster, anything can be that. And continuous, that's what continuous deployment means. And there's another term called continuous delivery. So continuous delivery is similar to continuous deployment, but the only part where it's going to differ is someone have to manually approve it. So it's another practice. Let's say you have to someone have to manually authorize the deployment to a particular target environment. Then you can implement continuous delivery. So that's what CI/CD means. Now let's have a look at GitLab CI/CD. So GitLab CI/CD is just another part of GitLab. So GitLab itself, are presenting to ourselves as a complete DevOps platform. So they got everything. So the GitLab CI/CD that we are going to talk today is just another part of that. And using GitLab CI/CD, you can implement all those continuous methods that we are talking about. That is continuous integration, continuous deployment, or continuous delivery. And using GitLab CI/CD, you can build your code, test your code, publish your code. And the advantage is you don't have to have any other third-party application or integration needed to do that. Everything is in a single place. So you don't have to break your head configuring some Jenkins servers, or maybe connecting to Circle CI or Travis, some other CI/CD tools like that. Everything is in single place. So in this slide you can see a diagram. So this diagram represents the GitLab's workflow. So I'll explain this. So let's say you're a developer, and you have your code stored in GitLab, basically a Git repository. So, and you're working on a new feature. So what's going to happen is in GitLab, you got options to create issues. Issues are nothing but a task that can be assigned to someone. So the flow is like this. If you're working on a new feature, you're going to create an issue first, and you can assign. So maybe your team lead can, or someone can create an issue and assign it to a particular person, or you itself can, you yourself can, create an issue and assign it to yourself. And from that issue, you're going to create a new feature branch that will be created from your mainline branch, whether it is master, main, prod, anything can be, anything can be that. And you're going to work on this new feature branch. And once you have this feature in place, what you're going to do is you're going to create a merge request back into your main branch. So that is where we talk about the collaboration, or multiple developers sharing code or integrating code into your main branch. So you're going to create a merge request for that. And once this merge request is in place, we can configure a merge pipeline in GitLab. So what this merge pipeline means is, it can do linting for you, test your code for you, or build your code and see if something is wrong. So before this code ends up in your main branch, you will actually have a well tested code in place. And after that is done, you can review your app, so people can collaborate and review the code, put some suggestions in place. And once everything is done, people can approve the change and merge that code back into main branch. And once it's in main branch, then we know, okay, this code is deployable, it's in a releasable state. Then what's going to happen is a new pipeline will kick in, that's going to deploy this code into a target environment, whether it's dev area or staging area or prod server. It totally depends on that. So that's what this diagram represents. So this is the GitLab workflow. So yeah, let's look at what's a pipeline. So in GitLab, pipeline is the top level component of continuous integration or continuous delivery or continuous deployment. A pipeline represents all these aspects in GitLab. And a pipeline contains two things, that's jobs and stages. So the jobs is like a collection of commands or scripts that you can, these are commands that represent what you want to do. So whether it's scripts or commands for building your code, compiling your code, or let's say doing testing, uh, you know testing, so these will be uh, commands and scripts for that. So that's what a job means, and it is the smallest unit in a pipeline. And stages, so stages are like a collection of jobs that are similar. So you can have multiple stages in the pipeline that groups similar jobs together. And it also represents the order of execution of your pipeline. So with stages, you can define the order of execution of your jobs in your pipeline. And the other thing I want to talk about is runners. So if I know a few of you are freshers, but there is people in this live who's already working in DevOps technology. So if you have heard of this tool called Jenkins, which is like the most popular CI/CD tool out there, in Jenkins they have this concept of slaves or workers, where this actual build will be happening, or the running of the pipeline will be happening. Similar to that, GitLab also have a similar concept called runners. So in runners, the actual job that you want to run in a pipeline will be executed by your runners. And the runners in GitLab is written in Golang, and we'll have a deep dive into all these terminologies that we are going to discuss here, right? Right, we are going to have a deep dive into that later in this session. So multiple jobs can be what's happened is, I have told you the stage have a similar group of similar jobs, right? So if there is multiple jobs in a stage, they are going to get executed in parallel. So at the same time all the jobs will be executed, and if the runner is capable of that, it's going to execute that. And the other thing is, if all that you need to take in mind is, if jobs in the all the jobs in the stage are executed successfully, then only it will move to the next stage, or else the pipeline will be failed. And also, if any of the jobs in the stage fails, the entire execution of the pipeline will be stopped. That's the default mechanism, but there is ways you can override this. And GitLab provides you different ways of configuring pipeline. There is different way you can configure a pipeline. So by default, there is this thing called basic pipeline. So this is a type of pipeline where where you will be having jobs that's running in stages, and you can use stages to define the order of execution. So that's what a basic pipeline means. But GitLab also provide you options to create pipeline that does not need uh, stages. So that's called direct acyclic graph pipeline, or DAG pipeline. What this means is it's going to run the job or execute the job based on the relationship between jobs. And compared to basic pipeline, the execution of these pipelines are much more faster, because it does not dependent on stages. And then we have merge request pipeline. So in the previous example that I told you, we can, when someone is going to create a merge request, a pipeline is going to run for that. So merge request pipelines are going to run based on the merge request events rather than normal commits. And then we have parent child pipelines. So parent child pipelines are, let's say you have a mono repository, or a big repository. So you need to write a complex pipeline. So parent child pipeline will help you with that. It's going to break down this huge pipeline into small downstream pipeline. And it will be really it is basically used for mono repositories where you have a large code base. So there's option for that. Then we have multi project pipeline. So multi project pipelines is a pipeline. You can execute pipelines between projects. So we'll talk about what's a project, and groups, all about them in upcoming slides. So these are all the different pipelines available in GitLab. Now let's compare GitLab CI/CD with some other CI/CD tools out there. So yeah, so in GitLab, one of the advantages, we have seamless integration with code repository. So what that means is you don't have to break your head to figure out how to get our code from a repository into our CI/CD tool. Everything is seamless because GitLab itself is a single platform where you store your code, where you have your pipeline, where you have your repositories, container registry, everything in one place. On the other hand, when we are talking about some traditional CI/CD tools like Jenkins, the integration to repositories are difficult. I'm not saying it's impossible. It's possible, but they are difficult because you have to create webhooks, or you configure a poll-based pipeline, something like that. And then for setting up CI/CD, there's no overhead. So you don't have to. You can just create a pipeline file in GitLab, and put that in the root of the repository, and GitLab is going to detect that and do whatever is defined in the pipeline. On the other hand, you have to configure Jenkins yourself. You have to install all the plugins. Then you have to basically configure what type of job do you want to run, whether it's a symbol job or a pipeline based job. So you have to spend a bit more time on that. And then we have pipeline then in GitLab, the pipeline files are actually created in YAML. So YAML is just another language which is easier to read, just like JSON, or some other easy to read language. It's like it's structured in a way that's easier to understand and read. On the other hand, when we are talking about Jenkins, it uses DSL. It's called domain specific language, and they are using Groovy for that. So in Jenkins, you are going to, or there are other CI/CD tools as well, but in Jenkins, what they're going to do is we are going to create our pipelines in Groovy, which is okay, but it's easier. It's not that easier to understand for a beginner. Then we have better support with container and Kubernetes, and GitLab has better support with containers and Kubernetes, because it can integrate to Kubernetes using agents. Even the runners have Kubernetes and a container executor. We'll talk about that later. And then in Jenkins, the integration to container and Kubernetes are tricky, because you have to configure the a plugin first and then authenticate to that. It's a bit tricky. Then when you're talking about GitLab, GitLab has both SaaS offering and self-hosted option. So we have gitlab.com, which is their SaaS offering, which is free, and you can create your repositories over there, do pipelines over there. So they have that option. On top of that, GitLab itself is an open source project, so we can host GitLab on our own infrastructure. And in Sendelon, we have our own GitLab. So uh, there's an option for that. On the other hand, when we are talking about Jenkins, there's no SaaS offering. You have to configure it on your own. Now let's explore what is GitLab. So once you create an account in GitLab, you're gonna be presented with a dashboard. So in dashboard, you can explore your project, you can explore your groups, you can explore your snippets. Then they have a menu header where you can do quick actions. So there's this is called the menu header, and over here you can create your projects faster. You can create new merge requests, you can navigate to your profile settings, you can list all the merge requests that's assigned to you. So this is what a dashboard in GitLab means. And then we got project. So projects are nothing but a Git repository, but it's not just as a Git repository, it represents much more things than that. So let's say if you want to create a Git repository for your project in GitLab, you're going to create a project for that. And every time when you're creating a project, it will always be under a namespace. So what this means is, let's say you are a new user to GitLab. So you have just logged in, and once you have created your account, you are going to basically create a namespace for you with the same user ID. So under your namespace, you're going to create these projects or repositories. So every time when this repository, you're creating a repository, it will always be under a namespace. It can be your namespace or a group. We'll look at what's a group later. And why we need projects in GitLab. So I have told you it's not just a Git repository, it encourages more. So it encourages collaboration. So you can add members to your repository or your project, so people can be a part of, they will have access to your repository, and then they can collaborate and work on the same code base. And the other thing about repository is it have built-in option for pipeline, then package and container registry feature. So on your left you can see this is on your right you can see this is a example of a project in GitLab, and this is where you'll have your code. And also like I told you, GitLab repository encourages collaboration, and it also comes with options for pipeline. So if you see here, the CI/CD actually represent the pipeline, and on top of that you can also create package repositories and container registries. So if you have some Docker images that you want to push, you can always push that to your GitLab repository rather than Docker, Docker Hub or some other container registry. And also if you have you're working on some project where you have some packages for your or dependencies for your application, like for Java we have Maven repositories, or for .NET we have NuGet repositories. So you can also host them here. And also the other advantage is the repositories the GitLab projects comes with a feature called Web IDE. So you don't have to clone this repository to your machine. You can directly work on this code in your browser itself. And the other thing is repositories can have multiple type of visibility. So what that means is your repository can be either public, because that what public means is people can just see your repository without logging into GitLab. So public repositories are mainly used by open source project. Then we have private repository. So private repositories are the repository where you need to be a member of their repository to access that. So it's like private, you don't have access to that. You should be, even if you are logged into GitLab, you should be part of that repository, a member of that repository to access that. And then we have something called internal, which is not available for the GitLab SaaS edition. It's only available for GitLab self-hosted one. What this means is, if we make a repository or a project project's visibility as internal, then whoever is logged into GitLab can see that. So that's what internal visibility means. Now I'll talk about groups. So groups are basically there to manage related project at the same time. So it's like we can say it's a collection of similar projects. So you can group similar projects in a single uh, group. It also supports creation of subgroups. So you can have a parent group, and under that parent group you can create multiple subgroups, and all these subgroups can have its own project repositories. And the other thing is, you can set permissions and visibility in group level, so that will be inherited by all the projects inside that group. So let's say if you want to create 10 repository of a similar application, then you can create a group for that. And if you want to make that private, you can make the visibility of that group as private, so all the projects underneath that group will be private. So someone need to have a membership in that group or that project to see that. And the other thing is, you can create runners are the a component of GitLab where your pipeline will be executed. You can configure runners in a group level. So if you have a group level runner, and all the projects underneath that group can execute their pipeline in this group level runners. The other thing is, you can also configure project level runners as well. And the other thing is, GitLab group comes with package and container registry, so all these projects can push their container images or dependencies into group level registries as well. And the other advantages is, I have told you about issues and merge requests before. So issues are nothing but small tasks that can be assigned to someone else. So if you have let's say 10 repositories or projects in your group, and all of them will be having different issues and merge requests and everything, so all those will be consolidated in the group level view. So that's another feature. Now let's talk about runners. So runners is a component of GitLab where the jobs in the pipeline will be executed. And runner is written in Golang, and it is distributed as a single binary by GitLab. It support execution of jobs concurrently. It is highly scalable, so it can execute your jobs concurrently. If your the machine that's where you have installed this runner supports that, it can run concurrently. And the GitLab runner comes with multiple type of executor. So few of the examples are Docker, SSH, Kubernetes. So you can have different kind of executors in a runner, and each of them have its own advantages and disadvantages. And then we when you're configuring a runner, we can assign tags to that. So based on these tags, our pipeline can be assigned to this, the jobs in the pipeline will be assigned to that runner. So let's say if we have a job that has tag in it, so that job will be executed in a runner which have the same tag. So on your right you can see few of the shared runners that's available in GitLab, and whatever is highlighted in the blue bubble, those are tags. So if I mention shared windows tag in my pipeline, that job will be executed in this particular runner. And runner support, the GitLab runners executor actually support all kind of shells. So it supports bash. So if you are working on Linux or Mac, you can use bash. Then it support Windows core or PowerShell core. And then there are different types of different classifications of runner in GitLab. So you can create a shared runner, a group runner, or a project runner. So I'll explain what are these. So a shared runner is what is available for you uh, in GitLab, or the other words, these shared runners are configured by the administrators. So in gitlab.com, which is a SaaS offering, shared runners are already there for you, where you, let's say if you want to execute a pipeline, you can use shared runners for that. But if you have a self-hosted GitLab, that means can configure a shared runner, and this shared runner will be available for all the projects in that GitLab instance. So that's what a shared runner means. And then we have group runner. So group runner, just like I've shown you before, you can create a group, and under that group you can create a runner, and this runner will be available for all the projects underneath that group. And then we have project based runner. So project runners are basically the runner that's assigned to a particular project, so the pipeline of that project can use that runner. Now let us look at the architecture of GitLab runner. So let's say if we have a GitLab server and we are going to configure a GitLab runner. So there is two process or two steps to this. First, you have to register your runner to your GitLab instance, and then there's assigning of jobs into runner. So we'll have a look at the flow of that. So let's look at registration first. So if you want to register a runner, you're going to hit a particular API of GitLab with the endpoint API v4/runners with a registration token. So you are going to use a registration token to register your GitLab runner into your GitLab server. And if the registration token is valid, the registration will be successful, and the GitLab server is going to return a runner token for that particular runner. So during the registration process, you can assign what kind of tag you want, what type of image we should use for this runner, and you can even select what kind of executor we want to use. So let's say I have used Docker executor here while configuring the GitLab runner. Then now we will have look at how the flow is like. If you want to run a pipeline, how that actually works. So job request and handling. So what's happening is every time the GitLab runner will be polling our GitLab server using gRPC. So this querying will happen occasionally based on an interval. So what it will do is, now it got the runner token, right? It's going to ask GitLab, okay, is there any jobs that I can run by hitting a particular API called API v4 jobs request. So it's going to ask GitLab server, okay, is there any job that I can execute? So if there is a job, then that job payload will be passed to the GitLab runner along with a job token. So what this job token means is, using this job token, the GitLab runner and the executor can authenticate with GitLab to actually get your code. Since it's Git, you have to basically authenticate to that first. So this authentication for cloning that particular code by the runner executor will be handled by job token. So once it got the job payload and job token, the actual job will be passed by the GitLab runner back to the executor, where it's going to clone the repository first. So it will clone the source branch or source tag using this job token. And with the same job token, it can also download artifacts from GitLab server. We'll have a look at artifacts, runner in everything in the demo session. And then once, let's say, the pipeline is completed, the executor will return the job output and the pipeline status back into the runner, and the runner will pass that back into GitLab server along with the job token. So this is how the flow is, and this is the architecture of GitLab runner. Now we will have a look at the pipeline file. So in GitLab, the pipeline file is by default named as gitlab ci.yaml. But there are ways you can change this. But by default, if you create a particular file with this name and put it in the root of the repository, GitLab is going to take whatever is in that file and going to execute that. So the GitLab ci.yaml file is a collection of scripts that's grouped into jobs. So the jobs are like the smallest unit where you have commands on script for building or testing or doing whatever you want. Then it supports grouping of independent jobs into stages in a defined order. So you can put jobs into stages, similar jobs into stages. So I'll tell you an example. If you look at the right side, we have two stages, build and test. And what this stage represents is, here you can see three jobs, and the first job is under the build stage, which represent building of your application. And we have another two jobs in place which is falling under the test stage. So these are similar jobs for testing your code, so it is grouped under this test stage. So that's what that means. And the pipeline file is written in YAML, and it is saved at the root of your repository along with your application code. So you don't have to keep your pipeline anywhere else, like in Jenkins, or where you can write your own you know pipeline file elsewhere instead of keeping that in your repository. And the other advantage is, you can just like your application, you can also keep track of the changes in your pipeline, and you can see the entire history of what all things got added, removed from that pipeline. So it's another advantage. And the pipeline file support variables and files. We'll have look at each of these terms down the line. So you can use environment variables, and all these encourages better security. You don't have to hard code anything on your pipeline. And GitLab pipeline support dependencies and caches. You can have dependencies, or you can create artifacts from your pipeline, and then you can also create caches, which gonna improve uh, the speed of your execution of your pipeline. And the other thing is, GitLab pipeline also supports templates. So the templates are like a reusable pipeline. So you can include n number of templates to your pipeline. Let's say if you have a complex pipeline, and the task of that pipeline is reusable, so you can use templates for that. So by this, your pipeline will be much more efficient and reusable, and also it's easier to read. Now the pipeline, the GitLab pipeline can be triggered using events. Multiple events are there in GitLab, or manually for continuous delivery purpose. And then it also supports creation of rules for creating more complex workflows. So GitLab pipeline has an option for that. Now let's have a look at jobs. So I have told you jobs are the smallest unit in a pipeline, where you'll be having this collection of scripts or command. And these commands or script can represent anything, whether it's commands for building your code, compiling, or doing unit testing, or doing code coverage, or even a deployment task. And jobs in GitLab pipelines are created using a bunch of keywords that we are going to define in the pipeline file. So on your right, you can see an example job. So it have so many keywords in it, which is predefined by GitLab. So if you have these keywords in your pipeline file, then only the GitLab pipeline will be executed. So I will explain few of them. So what is a stage? So I have told you this before. uh, you This is used to specify a stage where this job is part of. So in this example, this get cert job is part of generate stage. And then we have image. So image is basically there to define a Docker image to run this job. So the other advantage that I told you is GitLab have better integration with Kubernetes and Docker. So you can run your pipelines job in a temporary container that has this binary that you need already. And then once the task is over, it can get rid of that container. So in this example, I'm going to use this particular Docker image. So this is an example job where I'm going to use Lego, which is an open source tool using which you can create SSL certificate. And it's really useful if you need to create wildcard SSL certificates. So they have an official Docker image for that. I'm using that here. So for running this particular job. And then we have rules. So rules, like I told you, rules are like statements that will determine whether to execute this job or not. So like the rules are like used for conditional execution of your jobs. And then we have before script, which is another keyword. So it is an array of command or script that you want to run before the main job script. So here I'm just using that main script to to view the version of Lego that I'm going to use. And then we have the script keyword, which is another array of commands or script that you want to execute using your runner. So here, this is the actual command that I'm using for generating my SSL certificate. And then we have a keyword called artifact. So I have told you your pipeline can have dependencies between your jobs. So artifacts is used to specify a list of directories or file that you want to save as a job artifact. So what this job artifact, I'll explain this to you down the line. We are going to dive deep into this artifact later in this workshop. And then we have cache. So caches are a list of files or directories that you want to cache between jobs. So caches, just like the term cache, it's going to improve the pipeline's performance because it's going to cache few things that can be reused by future pipelines or jobs that are dependent. Then we have tag. So tag is basically used to specify a runner from a list of runner. So if I put a tag here called shared, and if I have a runner with the same tag, this job will be executed in that same runner that have shared tag. Now we have stages. So stages are used to define the order of job that you want to run. And a stage can have 0, 1, or many job to execute. So basically, let's say I have a publish stage here. I can have 0 jobs to execute in that stage. It won't break my pipeline. And I can put 1 job in that or n number of jobs. And each stages in the pipeline are executed sequentially by their defined order. So what this means is, in this example, you can see I have 2 stages. So each of these stages will be executed sequentially. So the generate stage will execute first. So whatever jobs are there under this generate stage will be executed first. And once all of them are successful, it will move to the next stage, that is publish. So that's the default mechanism. And all the jobs in the same stage are going to run in parallel. So let's say if the generate stage have 3 jobs like get cert, all these 3 jobs will run at the same time. So this will be useful for you to do different kind of testing. So one job can do unit testing, one job can do security testing, one can do secret detection. All these are like not dependent to each other, so they can run in parallel. And the other thing is, if all the jobs defined in a stage are successful, then only it will move to the next stage. Or if any of the jobs in any of if any of the job in a stage fails, by default it's going to stop the execution. It will not move to the next stage. It will mark the pipeline as failed. And if you have not used if you're not going to define the stages keyword in your pipeline, and you're going to create a basic pipeline in GitLab itself will define 3 stages by default. Those are build stage, test stage, and deploy stage. So yeah, this is what stages means. And now we have variables. So I have told you GitLab support variables, and it is used for making your pipeline more dynamic instead of hard coding the secrets or whatever value you want to use. So these are in GitLab, what variable means is these are environment variable that will be available for the executor, the GitLab runners executor. And these variable will detect few things. So based on variable, you can control the behavior of the job and the pipeline. And you can use variable to store secrets that you want to use or reuse in your pipeline. For example, you can see I have AWS access key, private key, the secret key, and AWS region. So these are all secrets that I don't want to expose to anyone else. So I can use variables for that. And also you can avoid hard coding values into your pipeline file by using variables, which is going to make it more dynamic. And there are 2 types of CI/CD variables option available in GitLab. So you can have a CI/CD variable of type variable, which is actually like a key pair value. So you have a key, let's say AWS key ID. This is the variable name, and I will have a value for that. And the other option is file. So file is like you can upload a particular type of file into GitLab. It can be some Kubernetes, authentication config, or it can be a private key, anything like that. And if you are and when you want to use these particular files in your pipeline, you can refer to those files using that variable. So those are the different types of CI/CD variables available in GitLab. And the other option is you can mask your variables and also make it as protected. So what this masked means is, you let's say I have AWS access key here, and I have a bad actor in my team who want to expose this key so that he can take advantage and maybe do some crypto mining in our AWS account. So he's a developer who is a member of who has access to my repository. So let's say he's decided to edit my pipeline and put another extra command saying echo then the variable name. So in Linux, what it's going to do is it's going to show output the value of that variable. So if I have not marked this particular variable as masked, what's going to happen is the output of the pipeline will have the value of this particular variable. So he can basically grab that and do whatever malicious thing he want. I'm just talking about a scenario, okay? So if you want to avoid such situation, you can mask a variable. So even if the guy want to expose this in the output of the pipeline, the value will be will not be shown. It will be saying that it's masked. And the other thing is, you can be protected. What this protected means is, in GitLab you can create branches. Since it's a Git repository, you can create branches that are protected. So what this protected means is, these are some restriction that you can put over a branch or a tag, saying who has access to push or push directly to that branch, or who got access to merge code into that branch. So this is what a protected branch means. So if you make a variable protected, those variable will be only available for protected branches. So that's what the term protected means. And then we have different levels, or different ways you can define a CI/CD variables in GitLab. So first one is predefined variable. So this one we are not this one is predefined variable. So this is the variables that are available for us to use in our pipeline from GitLab. So I will tell you a few example. So if you want to find what branch that you are going to use for this particular pipeline, we have a variable for that. That's called CI commit branch. So the value of this variable will be the branch in which the pipeline is going to get executed. So there are a few predefined variables in GitLab that you can use to detect the flow of your pipeline. And then we have pipeline variables. So these are the variables that you can define in your pipeline using variables keyword. We'll have a look at that in our demo. And these variables can be global or local to a job. So you can create a just like coding, you can create a global variable which is available globally for the entire code. So similar to that, you can create a global variable in your pipeline using a variables keyword, and this variable will be available for all the jobs. Or you can also create a job that is only available for a particular job. You can also create a variable that's only available for a job. And then we have project variable. So project variable is the variable that is only available for that particular GitLab project. We can define CI/CD project variable under settings of a project, and this is basically used to save secrets, just like this one. And we have group variables. So similar to project variable, we can have CI/CD variables defined under a group, and these variable will be available for all the this will be inherited by all the projects in that group. And then we have another type of variable called instance variable. This one is not at all available in GitLab SaaS edition. This is available in self hosted GitLab. So these variables are defined by administrators. And so let's say if your company is having a single AWS account, and you have a single IAM user that is commonly used for all the AWS access. then the administrator can create an instance level variable so that these IAM access key and secret will be available for all the projects. So that is what an instance variable means, and this is not available in gitlab.com. Now let's have a look at artifacts. So artifacts are the list of files or directories that is attached to a job. So these are artifactories basically some kind of binary or a directory that you want to pass between jobs or that you want to download. So on your right you can see an example. So if I have a job artifactory defined, I can actually download that, or it can be passed to upcoming jobs. And the artifacts in GitLab are defined using artifacts keyword. And once the artifacts is created in GitLab, after a job execution, that artifact will be archived into a zip format and it will be sent to our GitLab server. So the artifacts are not actually stored where the runner is. So once the job execution is successful, the artifact will be uploaded back into GitLab server. So whoever want access to that can either download that from the gitlab.com or the GitLab user interface, or let's say if there are downstream jobs that need this artifact, it can download that from GitLab server. So the default mechanism is the jobs in the later stages by default download all the artifact from the previous jobs in the earlier stages. So let's say if we have 3 jobs and the first job is creating an artifact, the 2 jobs down there is going to by default download this artifact from the first job. But you can control this behavior using dependencies keyword. And then we have different type of the artifact support an array of arguments that you can use to uh, change the way the artifact works. So few are name, paths, expire in when, but there are other keywords as well. So the name represents the name of the artifact to be created. So over this example, you can see I'm saying LE wildcard cert. So the artifact that's going to get created will have the will be of the name LE wildcard cert dot zip, because it will be an archive. And then we have another argument that says paths. So path means it's a list of or an array of files and directory that you want to uh, make an archive of. So this can be a binary or maybe a directory. So in this example, I'm going to create an archive of this particular certificates directory, and this path is relatable to your project directory. So project directory is like the directory where your code will be cloned. And then we have expiry in. So you can set uh, a limit over this artifact. So after that time limit is over, it's going to get expired and will be deleted from our GitLab server. So in this example, I have put a limit of 10 minutes. After 10 minutes, I won't be able to download this artifact. And then we have another keyword I have not used in this example, which is called when. So when will decide whether to upload this artifact on job failure or not. Then we have cache. So caches are basically another list of files or directory that you want to cache between jobs. So I will say you an example. Uh, so let's say if we are working on a Node.js project, and we all know, or some of us know, Node.js requires dependencies, and these dependencies will be listed in our packages.json file, and these dependencies will be downloaded to a folder called node modules. And sometimes these node modules will be huge for a bigger project, and every time if you're downloading it, it's going to increase the time of execution of your pipeline. But instead you can use the mechanism of caches in GitLab pipeline, where you will be downloading it for the first time. Then what GitLab will do is it's going to make a cache of that, and it will be available for your next pipeline or next job. So you don't have to download it again. it will be there for you. And then yeah, it will also eliminate downloading of dependencies in subsequent jobs. Yeah. And then the other thing is, the caches in pipelines are defined using the cache keyword. So you have an example on your right here. So you can create the cache in your pipeline using cache keyword. So by default, the caches are not shared between protected and unprotected branches for security reasons. I have told you what is a protected branch. So by default, these the caches of a protected branch are not available for unprotected branches. And also, if you want to, if you have a job, by default, the let's say if we have three job, a cache is created for the first job. The second and third job will download the same cache. But let's say the third job is a deployment job and it does not need to download this cache. You can disable that mechanism in your pipeline by putting an empty array after your cache keyword. So what this will do is, if you put this in your job, that job won't download any cache or even create a cache. And then uh, GitLab can have a maximum of 4 different caches in a job. So you can have 4 different type of caches in a job. That's the upper limit. And I have told you the artifacts won't be saved where the runner is. It will be uploaded back into GitLab, but the caches are actually stored where the runner is installed. So let's say if you are using a Docker executor, the caches will be in a Docker volume. Or if you're using SSH executor, the caches will be in a directory of that host machine. But you can override this mechanism by configuring an object storage in place, maybe a Google GCP bucket or S3 bucket. If you have enabled this object storage in your GitLab runner, so it's going to upload these caches back into S3 or this object storage once the job is successful. And we have an array of argument that's supported by the cache keyword. So I'll explain few of them. The first one is key. So the key is used to give a unique identity for the cache. So you can have a key, a static key name, or you can have you can put a variable over there. It supports a lot of things. So this key is there to uniquely identify that particular cache, because you can have four type of caches. So you can put different keys for these different caches. But if you, let's say if you're not using the key argument, by default GitLab is going to use default as the key name for that particular cache. Then we have path. So just like artifacts, these are like an array of files and directory that you want to cache. Then we have policy. So policy will is used to change the behavior of your uploading and downloading of your cache. So the default policy is pull and push. So first it is going to check whether there is any caches available. If it's there, it's going to pull that cache. And once the job is successful, the same cache will be, the updated cache will be pushed back into wherever it is, whether it's Docker volume or S3 bucket. That's a default mechanism, but you can change the uh, uh, property of that policy, that mechanism, using policy argument. Then there is when. So just like artifact, it will determine when to save the cache based on the job status. So you can save a cache for a successful job, or you can always save a cache, or you can save a particular cache if the job is failed. So that is used for that. Now we have rules. So I have told you rules are used to have conditional execution of your pipeline. So the job will determine, jobs are actually used to either include or exclude jobs from a pipeline based on few conditions. And the rules are evaluated during the creation of the pipeline. And if the rule is the rules are you can have multiple rules in place, and they are evaluated in order. And if a match is made for the first statement, then rest of the rules are ignored. And then you can define rules in your pipeline using rules keyword. And then there are two types of rules available in GitLab. there is job rules and workflow rules, and there is an array of argument that you can use in your rules keyword, and they are and here I have mentioned them all. So you can use if clause. So using this you can create statements or conditions in your pipeline, and if those conditions are true, then it's the pipeline will be executed, or it will be excluded if it's false. Then we have changes. So similar to if, the changes an argument is actually used to run a job or a pipeline if a specific files or a set of files got changed. So we can run a trigger. I'll say you an example rule. We can always trigger a pipeline if the Docker file in that repository is changed. So for that we can use changes. And then we have exist. So what exist do is it will check whether a particular type or a particular file exists in our repository. If it does, then that job will be executed. If not, that job will be excluded. Then we have something called allow failure. So what this will do is, uh, I have told you by default, if any of the job fails, then the entire pipeline will be marked as failed, and all the other subsequent jobs down the line will be ignored or they will be skipped. But you can change this mechanism. So let's say if you have a job, uh, and it can fail, uh, that does not affect the entire pipeline, and you can use this allow failure keyword as true. If it is mentioned as true, then even if the job fail, the execution of pipeline will not be stopped. The rest of the jobs can still run. Then we have variables. So I have told you there are different ways you can define variables in GitLab. So this is another way you can define variable in GitLab based on rules. So if a statement in the rule is true, is whenever it's evaluated true, then we can create a new variable. Then we have when. So when is configured to when it is when is used to configure a condition in our job. So the condition can be always. This means always run the job. And we have something called on success. So on success means if the job status or the pipeline status of the previous job is successful, then run this particular job. Then we have something called on failure. On failure means if the previous job is a failure, then execute this job. Then we have never. So with this we can put a condition, and if the condition is true, then never execute this job. Then we have manual, to manually run this job. Then we have delayed, so we can delay the execution of job for few minutes or hours. So I will show you an example of job rules. So here I have a sample job. This is basically a job for running an Ansible playbook. So I have this job called deploy service, and it's falling under the stage deploy, and I'm using Ansible CI image to run that. And here I'm saying dependencies. So if you remember, I have told you by default the artifacts will be downloaded into rest of the jobs in the pipeline. So if you don't want to download any artifacts, you can use dependencies keyword. And if I put an empty array for the dependencies keyword, even if there are n number of artifacts in the jobs before deploy service, this job will not download them. And here here's a way you can deploy a pipeline variable. So this is a local variable that's only available for this deploy service job. And so these are few environment variables for Ansible. And here you can see I have rule. So this is a job rule. Here I'm saying if the commit branch is SaaS dev. So let's say the pipeline is going to run for the branch called SaaS dev. Then I need to create a new environment variable called dev, findev, and the value is dev. And if the branch is QA, then I need to create an env variable called finenv with the value QA. Then I'm saying if the branch that's triggering this pipeline is SaaS prod, then I should never run this job. And then we have the script, and then we have the tag to assign this to a runner. So I'll explain the flow. So let's say I have committed my change to SaaS dev branch. So this statement will be evaluated to true, and rest of the rules will be ignored. But let's say if the branch that I committed is not SaaS dev, it's SaaS QA, it will check this first condition, it will say it's false, then it will move to the next one. And if this is true, then the third one is ignored. And let's say both of them are false, then it will come to the third rule. And let's say if the change did happen in SaaS prod, then the condition is never run this job, so it's not going to spawn this job in our pipeline. So this is an example of job rules. And we have told you we have two types of rules. Then the other type of rule is workflow rule. So workflow rule is used to control the pipeline's behavior. So what this means is, based on your workflow rule, you can uh, create a pipeline or spawn a pipeline, or even ignore the execution of a pipeline. And then if the rules are evaluated to true, the pipeline is created. If it's false, yeah, it's ignored. So I'll tell you this example. So we have workflow rule here. We are saying the first condition is, if the CI pipeline source, this is a predefined variable available in GitLab. So I have told you the pipeline can be triggered using events. And we have so many types of events in GitLab. We have push event, web event, merge request event, API event, and so on. So we are saying, if the event that is going to if a merge request event happen, never trigger this entire pipeline. So we are saying never. And let's say if no merge request happen, then it's going to come to the next rule. So next rule is if the changes happened uh, to these branches. So I will explain you this complex rule. We are checking whether the change happened to SaaS dev branch, this is or, then to SaaS QA branch or prod branch. If the changes happen to files listed here, so we can have an array of files or directories mentioned under the change argument. So what this rules do is, if something got changed in the service folder or API folder or the pipeline folder or the Docker file or any Gradle file for these branches, then the pipeline will be created. That's why we have always. So this is what a workflow rules means. So yeah, that's it about the basics of GitLab. Now we will look at a demo using GitLab CI/CD for a Terraform pipeline. And also we will be sharing these slides in our public forums like LinkedIn, and you can refer these. So these are the official documentation pages for GitLab. You can learn more about them here. And we have also mentioned the GitLab repository that we are going to do this demo today. So this will be shared after this workshop, after the streaming is over. So guys, can I proceed with the demo?
Yep, I guess. Yeah, I'm just seeing the chat. So far, how is everyone feeling? So everyone is here on the same page with us, or is there any deviation? Okay, I can see a lot of yeses here. So yep, let's proceed ahead with the hands-on.
Okay, great. So here
Thank
is
you.
our GitLab. So this is my GitLab account. So here, this is our Cloud Clan group. So in this Cloud Clan group, I can see the issues down here. So only a single project is there for this Cloud Clan group right now. This is the repository where we are going to use today for our demo. So this is a consolidated view of all the issues that is created for all the projects. Since there's only a single project and a single issue created, you can see that over here. And you can also see your merge request here. And then there is security dashboard. Then you can create register GitLab runner here. You can see your package registry, container registry, or dependency proxy over here. And there's settings. So this is what a group means. And in group, you can actually add members to your group like this. So there is there are few people who's already logged into GitLab and they want to be part of my group, I can invite them by their mail address or user GitLab username over here, and I can assign them a role. So there are different types of roles available. It's guest, report, developer, maintainer, or owner. The guest your users will only have access to just it's like a read only access, so they can see the code. Then we have reporter, who can create issues and do a few other things. Then we have developer. So developer access, for the people who's having developer access, they can actually do push and pull to your repository. Then we have maintainers. So maintainers can configure runners, access the settings of the repository of the group, things like that. And then we have the owner, which is like the owner of the group. He has the highest permission. So these are all the different types of roles available in GitLab. And then now let's dive into the demo session. So I'll first show you guys how to register a runner in GitLab. So here we are using GitLab SaaS, that is gitlab.com. So I will tell you how to register a GitLab runner, how to configure a GitLab runner. And here for today's workshop, I'm going to use a GitLab runner that has Docker executor in it. Okay. So for ease of use, I have created a Docker compose file, and I'm defining few things in here. So here I'm saying a service has GitLab, and this is the official Docker runner image available from GitLab. You guys can use this to configure runners. And then I'm naming it as Cloud Clan. The container's name will be Cloud Clan. And if you see, I have two volumes added here. So what this means is I'm passing my Docker socket of my host machine, that is my laptop's Docker socket, into this particular container, because we are going to create a Docker executor, which is going to create containers for each jobs. And then this is the location in your runner where the configuration of your runner is defined. So I need to persist that. That's why I'm mounting this particular directory of our GitLab runner container back into my host machine, into a folder called GitLab runner. So here you can find a folder called config.toml or tuml. So this is the configuration file for your GitLab runner. And I'm persisting this because even if I turned off my laptop, next time I still want to use my runner. So the other advantage of GitLab runner is you can configure it anywhere. So you can configure that on your ARM machines, maybe Raspberry Pi, in your laptop, in your Windows machine, Mac. It support all kind of platform. So here I'm going to deploy that in my laptop today. So we'll start with the configuration part. So what I'm going to do is I'm going to spawn a container using this configuration. So the container is up. You can see a container is running with the name Cloud Clan. Now what I need to do is I need to get inside this container. So this is the command for using which you can get inside the container. And now basically what I'm going to do is I'm going to execute a command called GitLab runner register. So using this command, you can register your register your GitLab runner with your GitLab server. So I'm going to hit enter. So it's going to ask you a few questions, and it's really easy to set up. So by default, you can see what kind of architecture that is running. So here I'm using AMD 64 architecture. My OS is Linux. So it's going to detect all that. And here it's asking for a few questions. So here it's asking for the GitLab instance URL. So if you're using gitlab.com, you can use this particular URL. But let's say if you have your own self-managed GitLab server, you can use that particular URL. So I'm going to use this. Now it's asking for registration token. So if you remember, I have shown you the GitLab architecture. So when you're registering your GitLab runner, you need to pass a registration token. So you can get that token uh, from your So here today I'm going to register a group level runner, but you can also get this token from a project level as well. So you can, if you go to the groups CI/CD options, you can get the registration token from here. But I can also show you an example where you can register a project level runner. So if I go to my project, if I go to settings, then CI/CD, I have an option for runner. And if you see here, I can see shared runners. So these are all the runners that's available for me from gitlab.com, which is maintained by their administrators. So these are all the runners. So if I don't want to create any runner, I can simply use any of these tags in my pipeline, so that that job will be executed here. So let's say if I have a job or a workload that I want to run in a Mac operating system, then I can use this particular tag in my pipeline. So it's going to use this particular shared runner from GitLab. But one of the downside of this is, since the crypto got exploded in last few years, people were trying to make use of free resources available on the internet. So of course the runner is a machine which has CPU and RAM. So people were spamming and trying to make take advantage of this, and they were trying to run some crypto mining jobs in this GitLab runner. So what they did is, for if you are a free account, you have only 400 minutes per month for free for a particular runner. So that's why GitLab support option for having self-hosted runner that you can run on your own infrastructure. So if you want to create a project level runner, you can come here in the settings of the project and go to CI/CD. Then you can generate the token from here. This is the registration token. But for today's example, I'm going to register this runner as a group level runner. So I'm coming over here and I'm going to use this registration token and I'm going to enter it over here. Now it's going to ask me for the description. So I'm going to say Cloud Clan demo runner. Now it's asking for tag. So I'm going to enter a tag called clan runner. Then it's asking for maintenance node. We can skip that. But if you are a core, if you're an administrator or a cloud engineer who's going to manage this infra, then you can put a maintenance node. And then it's asking for what kind of executor I want. So here I'm going to use Docker executor. But here you can see the list of executors supported by this particular GitLab runner. We can have Docker SSH, Parallels, SSH, Instance, Kubernetes, Docker Autoscaler, Docker Machine, Docker, Docker Windows, Shell, or virtual machine. So today we are going to use Docker executor. So since we are using Docker executor, we need a default Docker image, because I have told you, if you are using Docker executor, the jobs will be running inside temporary containers. So you need to mention a default container for that, Docker image for that. So I'm going to use Alpine as my default image. So if I did not mention any image in my job, by default, those jobs will be executed using this container image. So I have mentioned Alpine and I'm using the latest image. So that's it. So the thing is registered now, and you can see the configuration is saved into a file called etc gitlab runner config.toml. So this is the repository the directory that I have mounted back into my host machine. So now what we're going to do is we're going to restart. I mean, this is not necessary, but I will show you why I'm doing this. If I do docker compose logs for this particular container, you can see it's just saying failed to config, because now only we have registered this runner. So it's just trying to this is like a default mechanism. You can ignore this. So I'm basically going to recreate this container again, and I will show you one more thing. You can refresh this and you can see the runner is up and running here, because we have already registered, and you can see the tag for that runner is clan runner, and the description you can see cloud clan demo runner. And what I'm going to do is I'm going to stop this container. I'm going to create it again. I'm recreating it again. And since this configuration is already mounted into my host machine, you don't have to re-register this runner again. So let's say at the end of the day, you can turn off your laptop, and the next day when you turn up, you can simply run this container, and this runner will be back online in your GitLab instance. So you can refresh, and you can see its last contact is just now, so it's still up and running. And we can see what kind of executor we are using, that is Docker. The architecture of my laptop is AMD 64, the platform is Linux. So you can see all these things here, and it's assigned to this group. Now what we're going to do is, I'm going into the pipeline demo right now. So yeah, let's go to the demo. So I have told you in GitLab's workflow, everything starts with an issue, which is not necessary, but this is the way GitLab works. So you can create an issue for yourself. So here you can create issues like this. You can click on issue, then you can give it a title, then you can either choose the type. So issues are basically tasks which can be assigned to anyone, or you can mention it as incident. So I'm creating an issue. I can write a description, and you can assign it to anyone, any member of your project. But since I'm the only one here, I'm going to assign it to myself, because I can also create tasks that is assigned to me. And there are a few more options, but these are beyond the scope of our workshop today. So I'm going to create this issue. So this is how you will create an issue in GitLab, and you can do a lot of things in issue. And we are not going to cover them today because this is a CI/CD workshop. So on your left, you can see there are few infos you can see about this repository. So under project information, you have something called activity. So this is going to list down all the activities that had happened from the creation of this repository. And then we got labels. So labels are there in place to we can use labels for different purpose, and these are basically used for creating issues. So when you're creating an issue, we can label them. So there will be tasks assigned to different teams, right? There will be testers or developers or different type of features. So you can basically create labels for that and assign that to that particular issue. Then we got members here. So using members, you can invite new members to this repository. But if you have invited them into the group, then those members by default inherit permission to this repository. But you can also invite individual members to this project as well. Then we got repository. So repository is like I have told you, Git project is basically a Git repository. So over here you can explore the files under your repository. You can explore different branches. You can create new file or create new branches or tags. You can There is option for you to clone this repository. Then you can download this repository as an archive. Then there is option for you for the web IDE. And then we have commits. So if you are familiar with Git, we have the concept of commits. So you can explore all the commits in this particular main branch, but you can choose between branches. So these are all you can explore your commits over here. And then we got branches. So here's the place where you can see all the branches of this particular repository. Then we got tag. So tag is another feature of Git. So if you are creating tag from a particular branch, those tags will be listed over here. Then we got some statistics from the contributors, few graphs and other things. So this is Git graph. This will show the timeline of things that's happening in our repository. Then we got merge request. So here is the place where you're going to create merge request from one feature branch into main branch or any other branches. And this is the CI/CD option. Basically, is the view of this is a place where you can see your pipeline, and you can also run pipelines from here. And this CI/CD option also comes with pipeline editor. So this is a dedicated place where you can edit your pipeline. pipeline file, and also it will have auto completion option. You can also validate your pipeline, because since this is written in YAML, the indentation of your file is really important. So if the indentation is wrong, it is going to check the file and tell you, okay, something is wrong in this particular line. You can visualize your pipeline. So these are all the jobs in my pipeline, and these are all the stages. I have got prepare stage, validate stage, plan, and provision. And these are all the jobs that's falling under this particular stages. I can see them here, then I can validate them, then I can see merged view. So what this means is, if you have a complex pipeline where you're calling templates or downstream pipeline, you can see a consolidated view of that, like a merged view of that over here. Then we got jobs. So these are all individual jobs and their status. And then we got artifacts. So if you're creating some artifacts in your job, you can see them over here, and you can download them. And if you have created an expiry time for them, they're going to get expired. Then we have got schedule. So the schedule option is there to create schedule pipeline, which is similar to a cron job. So let's say you want to create a pipeline that's going to you know uh, run a specified time. You can uh, use the schedule pipeline for that. Now we got only 15 minutes left, so I'll just dive into our session. So for this demo, we are going to create a pipeline for Terraform, and we are going to create a S3 bucket for using this pipeline. So I'm not going to do a deep dive into our Terraform code. I will explain the pipeline. So the pipeline is starting with the keyword workflow, and the workflow, under workflow we have a rule, and here we are saying the pipeline should only trigger on an event called web, and the branch where the where the event happen should be default branch. So these are all predefined variables in GitLab. And what this pipeline source means, I have told you there are different events available in GitLab. Just like in the previous example I showed you about merge request event, here I'm saying web event. So web event is where you manually run your pipe. Whenever you're manually running your pipeline, it's a web event. And then here I'm saying the default branch, the commit branch should be the default branch. So my default branch is main branch. So if I commit into my main branch, then this will be true. So here I'm saying I should be the pipeline should only trigger for the main branch, and the way of triggering will be manual. If that's the case, always spawn this pipeline, and for any other kind of events, ignore this pipeline. So it's not going to create a pipeline for any kind of other events. And here I'm defining few pipeline variables, and these are all global variables which is available for all the jobs in this pipeline. So here I'm creating a region variable with the value AP South 1. Uh, and one of the advantages is you can create a drop down view uh, for your pipeline variable. I'll explain you this when you are actually executing this pipeline. You can also put a description, and then we have resource variable, and we are saying this is S3, and then we have a project tag, which is an empty variable for now. I'll tell you why we have it like that. And then we have few actions, and the default value of action variable is apply, but we got two more I mean two more options, so apply or destroy. And I got the description. Then we have a Terraform tf root variable which have a value like this. So what this will evaluates to AWS region slash whatever the value of region is, then whatever the value of resources, then whatever the value of project tag is. So you can create complex variables like this. And then we have Terraform state, which is having the same value as the project tag variable. And then we have stages. I have got 4 stages: prepare stage, then validate stage, and plan and provision stage. And then we have something called default. So default is a keyword that you can use in your pipeline. If you are using this, this is used for basically setting the default uh, image or default script that you can use for all your jobs. So over here, I'm saying by default, all the jobs in my pipeline should use this particular Docker image to run uh, the job, even though we have created a default image in our runner that is Alpine. So let's say if you are not defining any image over here, by default Alpine latest image will be used by the executor. But since we are defining an image here, these image will be used by all the jobs. And I'm using this particular image from GitLab itself because they have this image called uh, Terraform image that have a wrapper inside of them, which have some advanced features. And here I'm saying I should create a cache with the key tf cache, and it should cache this particular folder. And then before script is I should always check into this Terraform root folder. Then the tag is uh, cloud clan. So what this means is I should run all the job by default in a runner that has this particular clan. But if you remember, we created a runner with clad runner as its tag. So I need to update this pipeline. We are going to do that. Then we have few jobs. So first job is to do Terraform init. So if you're familiar with that, you'll know we need to do an initialization of Terraform first. So we have a job for that. And in that job, we have something called resource group. So resource group is used to, if you have some similar jobs that is going to it executed, you can use resource group to actually group them into a queue. So if I'm going to use the same resource group for all the job, then it will be acting like a queue. So the first job that's part of the resource group will be executed first, and rest will be waiting. And this is to actually order your pipeline's execution, so that nothing might go wrong, especially since you are working on Terraform using this. And then we have a job level rule, and in this rule I am saying the action should not be equal to destroy, and this particular project tag should not be null. If that's the case, then execute this particular job. And then we have validate job with a similar rule. And then we got plan. So here we are going to do the Terraform plan, and we got also similar rule over here. Then we got the apply rule. So this is the place where we are going to apply our Terraform manifest and actually do Terraform apply. So if you see the plan job, here I'm saying do a Terraform plan. Here I'm using GitLab Terraform. This is the wrapper I was talking about. So what this does is it will do a plan and save that into a file, and that file will be available for Terraform apply. So here, since it is going to saved inside a file, the plan will be actually saved as a file called plan.cache. I'm going to create artifact of that. So when this job is going to get executed, once the planning is done, this particular plan will be uploaded back into our gitlab.com server, and it will be available for us 15 minutes. And then this apply job can actually get that particular job. So you can see I'm saying need uh, artifact from the previous job saying plan, and we are going to the apply job is going to download the plan from the previous job. And this particular, if you see the rule over here, this is a bit different. So here we are saying the action should always be equal to apply, and the project tag variable should not be null. And this action is a manual action. So since this is a Terraform pipeline, we should be really careful because we are doing provisioning things in cloud. So this is a manual pipeline, and this is a destroy job. So this destroy job will only be created if the actions value is destroy, and the project tag is non-empty. And this is also a manual job. So I will run this pipeline. So we have created, I have created a issue before. From this issue, I'm going to create a new branch and a merge request. So this is the new merge request. I have marked it as draft. I'm assigning it to myself. I'm creating the merge request. So now what I'm going to do is I'm going to do some updates to my temporary feature branch that I have created using my issue. And I'm going to open that in my web IDE. I'm not going to clone this repository to my laptop. So here in the pipeline, we need to make a small update, because we need to change the tag. So the tag for our new runner is clan runner, if you remember, or you can always go back and check that. So this is clan runner. So I'm using that same tag over here. So all these jobs in this pipeline can run in our local runner that we have created. And the other thing is, I'm going to rename this particular folder into Cloud Clan. So have made few changes to my pipeline. And remember, this is our temporary branch. This is not in our main branch. And the commit should happen in our main branch. And also the event should be web. Then only the pipeline will be triggered. So I will explain about the directory structure. So I will always have follow this particular directory structure for my Terraform code. I will say AWS. Then I will have a folder called region. Under this region folder, I can have subfolders for particular regions. So for this today's demo, we are going to use AP South 1, but I can have AP Southeast 2, Southeast 1, AP US West 1, something like that. And under this particular region, I have few folders for the resources. So today's resource that we're going to create is S3. So I have a folder for that. And under that, I have a folder here called Cloud Clan. So today we are going to create a bucket called Cloud Clan. And we have the manifest for that over here. So I'm going to do a commit. So I'm going to create a commit message. And once I hit commit, there's an option for you to create new branch or merge into the same branch. So since this is a feature branch, I'm going to merge into this feature branch. Now, if you see, if I go refresh, you can see the commit is actually listed here. And you can see the changes that's happened to the file over here. So these are all the changes that happened. And once the reviewing is done, I can see how many commits got into this particular branch. So once this is looking good, I can make this merge request as ready. I'm going to approve it. But basically, in a real world scenario, someone will be reviewing your changes over here, and they can also put comment like this, and they can do a lot of discussion over here. So this activity we can put write discussions over here. So they can actually do comments like this for reviewing. And then if everything is good, we are going to merge this branch into our main branch. Now this is not an automated pipeline, this is a manual pipeline. So we are going to run this pipeline manually. So I have few example here. So this is how a pipeline will look like if you cancel that execution of the pipeline. So this is a view of that. So here I have canceled the execution of init job. So this is a view of a cancelled pipeline. And here is an example of a failed pipeline. So here you can see two of these jobs got successfully executed, but the planned job got failed. So because this job is failed, the entire pipeline is marked as failed. And now we're going to do create a pipeline. So you can click on run pipeline. So if you're executing a pipeline like this, it will create a web event. So if you remember in our pipeline, we are saying the event should be web. So what we are basically saying is someone have to manually come to this pipeline option, then trigger the pipeline instead of manually running it. And this is not the only way you can run. You can have automated pipeline, but for this demo, since it's Terraform, someone have to manually do it, because they are responsible for creation of resources in cloud. So once you do this, you have few options. So if you remember, in our pipeline we have pipeline variables. Those values will be actually displayed over here. So for region we have a value of AP South 1, and for options we have only a single value, so we can't have a drop down menu over here. And for resource we are having S3, and for project tag it is an empty variable right now. Why it is like that? Because if you look at this particular variable, this one is the actual Terraform root directory where you want to run the Terraform plan and apply. So here we are saying the we need to execute Terraform plan and apply for this particular resource. So the value of this will be the name of the folder. So I have put that as empty, so I can add that value over here. And the action is either apply or destroy. So since I'm going to create a resource, I'm going to make the value, select the value as apply, and then I'm going to run this pipeline. And the other thing is, if the value is still remaining as empty, then the pipeline won't trigger at all, because it's not going to run any job. Because if you see the jobs rule, the action should not be destroy, so it should always be apply. And then the project tag should never be empty, it should not be null. So we should have this value in place, because you know I can simply delete this and try to run this pipeline. And if you can see, it's not possible, because that we have rules in place for our job. So I'm going to run this pipeline for you guys. Now if you see, this is, okay, let me refresh. So this is how the pipeline execution looks like. We have prepare stage, validate stage, plan stage, and provision stage. Under prepare, we have init job. So if you click on the init job, you can actually see its output. So in this job, basically we are initializing the Terraform directory, and it's going to pull this particular Docker image for us into our wherever our runner is installed. So in our case, it's my laptop. And I can also show you one more thing. If I do a log, you can see the GitLab runner is asking to the GitLab for jobs. So now it got returned with a job payload and the URL of my Git repository. And now you can see the log of what all things are happening. And since I'm using Docker executor, if I do Docker PS -a, you can actually see there are some temporary containers running for running my actual job. Now this job is successful. Now we can move between stages like this. Now I'm going to run a job for validating our code. So after the job is executed, those container will be removed by itself. So it's going to run this particular job to validate our Terraform code. So yeah, this validation is successful. You can see the job status has succeeded. And then I'm gonna go to the plan stage. I'm sorry about this. My internet is a bit messy today. There's nothing wrong with the pipeline. Okay. So I'm going to switch to plan. And here's the plan job. So each time it's going to use this particular container image, because we have mentioned that under the default keyword. So all these jobs that does not have any image per se defined into that job is going to use this default image under this default keyword. It's going to do the, yeah, now the plan is done. So this is how a Terraform plan will look like. So here we can see it's going to create three resources. That is an S3 bucket, an S3 bucket policy, and we are going to basically block the public access. So that's what this do. And also in this you know plan job, you can see we are going to. I have told you we are going to. We are using this particular image because GitLab Terraform image comes with a wrapper, and then that wrapper is going to basically write your plan into a file. So that file's default name is plan.cache, and we are creating an artifact of that, and it's available for 15 minutes. So if you see on the user interface, you can see, yeah, we have a job artifact. We can either browse that. So you can browse your artifact like this. So AWS, then region is AP South 1, then we'll have a folder called S3, then the folder called Cloud Clan, then this is the plan. Okay. So let me go back to our pipeline. Now you can see this is in a blocked state because our next job, that is apply, since our action was apply, is a manual job. So it will remain like that uh, as a blocked job. Someone have to manually come and apply it because you are provisioning resources in cloud and you should be responsible. So we have a manual apply job here. And also you can see in this plan jobs output, this will be deleted after 15 minutes. So right now this is available, but not for so long. This will be deleted after 15 minutes since it's mentioned in our pipeline. Now let's execute the provision stage. Under provision stage, we have in apply job. So you can either run that job like this by clicking this button, or you can, if you're in this particular view, on a top level view, then you can click on this play button. This is actually a drop down, and you can click this name, or you can go into this view, then click on this play button. So it's going to run that job for you. So yeah, it's executing. So you can basically see the resource got created, and here is the Terraform output. So we have created a bucket called, you know, GitLab TF Cloud Clan, and I can actually verify that. So I'm going to copy this, and I'm going to do so. The other thing is, I have told you each job is going to run in a container, and that container is temporary. So after the job is completed, those will be removed from the host machine or wherever this runner is installed. So here is an example of that. Right now, for in my laptop, only this GitLab runner is running. All those rest of the you know containers which was running this executing our job got cleared from my host machine. So I'm going to do verify whether the bucket got created in cloud. Yeah, so we have a bucket that got created right now. So this is an example of GitLab CI/CD, and I want to tell you one more thing. GitLab has a lot of features. It's not just a sample repository. So if I come back to this is not just a repository. It have a lot of features. Like I have told you, we got container repositories, container registry, package registries, and Terraform modules also you can create. Similar to that, we have another option called Terraform State. So in Terraform State, if you're familiar with Terraform, you know the concept of backends. So you can use different types of backend. You can create an S3 bucket has its backend. Similar to that, you can also create a Terraform backend in GitLab project, and it's basically an HTTP. The backend type is HTTP. So here you can see my state's name is Cloud Clan, and it will say which job was the one created this particular state and the details about it. And the other thing is, you can actually manage your Terraform states using your same GitLab project where you have your Terraform code. And from here you can either download that state, you can log this, so that when we are next time when we are running this job, uh, the resources won't be affected. You can also remove this state file and its versions in particular, because if you are using Terraform backend as S3 for object locking and versioning, you have to do some other stuff like creating DynamoDB tables and enable versioning in your bucket. But Terraform by default provides all that. It have state locking, it have versioning enabled by default. So all this is achieved because we are using this particular image from GitLab. This is an official image, and it have this Terraform wrapper that will talk to our project's Terraform state backend. So yeah, so this is an example of CI/CD in GitLab. I can also show you another automated pipeline quickly. I have that in place because you will have having this doubt: can we only create manual pipelines? Is there any option for uh, you know an automated pipeline? So I'll show you an option for that. So I have created another branch here called basic pipeline, and here I have another feature branch. So in this pipeline here we are saying we have a new pipeline. So like this you can have different kinds of pipeline per branch. So here the workflow says I should not trigger the pipeline for any merge request event, but I can trigger the pipeline for if the commit is happening in basic pipeline branch or a tag of this particular regex format. So you can also run a pipeline for tag. It's called tag pipeline. And this is basically a way of creating regex. So here I'm saying the pipeline, the tag's name should be prod dash continued by 8 digits. So if I have a tag of that type, then the pipeline will trigger for that particular tag. And here I have a single stage and this particular job under this stage with this particular image, and it's going to echo some stuff. So this is a feature branch, and this pipeline will only work for uh, basic pipeline branch. So I'm going to merge this, and that's going to create an automated pipeline for you. So this is how you create a merge request. So you can go over here, then create merge request, then select the source branch. Then our target branch is basic pipeline. If I merge this, this is basically going to create a merge request. So you can see all the changes over here. You can preview them, and then I can assign it to myself. Then I can also, there's an option for us to delete the feature branch or the source branch after the merge is accepted. So I'm going to create that. I'm going to approve it, and I'm basically checking this box so that once the merge happens, this pipeline basic pipeline feature branch will be deleted. And this is great feature because you don't have to worry about the housekeeping of your repository, where you'll be having like you are bloated with a lot of branches. So I'm going to merge this. So once the merge is over, it's going to create a pipeline. This is because we got the changes got merged into okay. So this is happening because not because we created a merge request event. We are not the pipeline will never be created for the merge request event. But once it's merged and the commit happened to basic pipeline, that's why this automated pipeline got triggered. So this is also possible. You can also create automated pipelines. So this pipeline just says echoes this, and that's it. So yeah, that's it, guys. That's it for the demo for today. And back to Akshay and Sankalp.
Hey, yep. Thank you so much, Akhil. Thank you. Thanks a ton, man, like for shedding the light on the GitLab CI in CD. So it was such an informative session, and both on the theoretical as well as on the practical part. So hands-on were also very much lucidly explained, and I hope that everyone was able to follow things throughout the session. And with that being said, like I'll just open the floor for any questions in case anyone have. So we have Akhil right now, so he can take up a few questions in the next for the next 5 minutes probably. And I know that we are over time, so yep. So if anyone do have any comment, any questions like related to GitLab or probably related to anything, just feel free to drop in the chat. So we would be happy to answer those things. Okay, so Silent Gamer and why Kunthan has just said that they liked your session.
Oh, thank you so much.
Okay, so we have a question from Swaroop. So I have one scenario related doubt. Let's say in the dev environment, we need automated deployment on every new merge request. In staging, we need manual deployment every time someone will verifies the changes and click on somewhere in the GitLab UI. So from there, things will get deployed into staging environment automatically. So yeah, so like Akhil, you are able to see the question.
Yeah, yeah, I can.
Okay.
So Swaroop, so about this particular scenario, we are not going to create merge request pipeline for this. So what your question is, if some changes end up in your dev branch or the branch that you want, then that should happen automatically. And let's say you want to promote this manually to your staging, right? You can basically do that using your rules. So you can create a rule saying if the git commit branch is dev, then always the rule will be they execute the script always, or if the branch is for stage, you can put that as manual. So in the pipeline view that I have showed before, right, under GitLab, there's option for you to whenever this particular rule evaluates to true for staging, then there will be this option for you to click on apply.
I see. Hope this answers your question, Swaroop. If you have any further follow-up question, yeah, feel free to drop in the chat. So Yashwant has asked, is there any opportunities work on cloud DevOps as an intern? So yeah, so there are tons of opportunity in the cloud to join as a DevOps intern if you are a fresher or just changing your basically you're moving out of a software development and probably trying to join as a DevOps engineer. So there are a lot of opportunities. So just you like to get started on the preparation part. Just make sure that you like you spend some ample amount of time in learning. Picking any cloud provider, let's say AWS, as your main focus part to know how things are being laid and being chopped down and works like yeah, inside the cloud. So yeah, just see different offerings that the cloud have and the challenges it solves. And then once you get started on the cloud thing, try to check on further more tools just to know the basics of Docker, Kubernetes. So this entire thing I've mentioned in the chat as well. So being a fresher, this should give you a good kick start to have some exploratory knowledge on the DevOps part. And then there are few companies who give you some training sessions. So there are a lot of companies. So we keep on posting such like job opportunities in our community thing. in our community WhatsApp group. So you can just join over there. So there you will be able to like come to know about such opportunities. And obviously there are multiple portals, so where you can just keep on just just try to keep an eye on like search portals. So let's say Insta Hire or Glassdoor, a LinkedIn job. So you will be able to find such things and try to leverage the LinkedIn. So just try to connect with your seniors, your mentors, or your colleagues, and yeah. So and just try to get some referral from like from those people in case in their company there are some openings. So I can see that I have worked as a software developer for 1.6 year, and now I'm looking into become a cloud DevOps engineer. So yeah, so since you have worked for almost close like more than 1.5 years, so you must be having some good amount of knowledge on the standard deployment procedures that you might have followed, probably some pipelines. Obviously, you must be super good at Git and all, like maybe familiar with Linux and all. So, or perhaps you must have worked on a few of the services on S3, like on the AWS, like let's say S3, EC2, and all. So it should not take much time for you to start exploring on the different tools and start applying for any open opportunities. So okay, yep, and okay, so says that honestly using Terraform for a start was so advanced. I enjoyed it, but then I'm a fresher, I guess. Yeah, so that like thanks for that feedback, say. So I would take this thing as a feedback. So yeah, if you want to learn Terraform, so basically, just to give you an overview, so Terraform is just a tool which is used to write infrastructure as a code. So we call it as IaaC, infrastructure as a code tool. So whatever resources that you create in the cloud, so let's say AWS, in AWS you create one S3 bucket, one EC2 instance, or one RDS instance. So all these resources can be provisioned through a code. So it is more like a declarative way to manage your infrastructure resources. So that is just about Terraform, but I would encourage you to, go and look out in case you need to deep dive into it. So yeah. Okay, so yeah, Yashwant. So you have a follow-up thing. You totally experienced in software industries, 3.6 years. May I have your LinkedIn profile? Yeah, sure. So I just dropped in my LinkedIn profile. So I also dropped Akshay's, and probably yeah. You. So let me drop Akhil's one also. Just give me a minute. So I just dropped Akhil's LinkedIn profile. So in case anyone have follow-up question, just feel free to reach out to Akhil regarding GitLab CI/CD, and yeah, whenever he have some time and bandwidth, so he'll respond to your queries. And yeah, so I have already dropped mine and Akshay's LinkedIn profile earlier in the chat. We'll drop it further again. Okay, thanks Akshay for dropping it out. So yeah, let's connect on LinkedIn. So in case you have any queries, if you are exploring or like a DevOps tools, so you can just do let us know. Feel like we can have a chat, we can have a call as per our availability, and we would love to guide you on such things. And also we have like we have connect with uh, few recruiters. So in case there are any openings, so just make sure that you you follow our LinkedIn pages, get added to the WhatsApp community, and yeah, so maybe you will be able to land a good job on the cloud side. So who knows? So sky's the limit. So yep, so make sure you follow us and do subscribe to YouTube channel. So we have further similar sessions coming coming in the next next subsequent weeks. So just stay tuned for the next set of good learnings that you are going to have. And yeah, so we have shared a feedback form regarding today's session. So just feel free to feel free to fill it out. Like what did you like the most about the session? Were you able to follow? Was the content too fast, too slow? Is there any area of improvement where we can improve to provide you even more quality content? So that would help us to improve a lot, and also at the same time it will help you a lot, so you will be able to follow the most. So I would humbly request each and every one of you who is present over here and have been following through till the end of the session to give your totally brutally honest feedback. So yeah, so that is the last thing that I wanted to say. And yeah, um, so Akhil, once again, we highly appreciate that you joined us over the weekend to deliver such a delightful content. So kudos, and thank you so much, Akhil, once again, on the
Thank you, sir.
behalf of all the Cloud Clan community. Yep. And yeah, last but not the least, to our audience. So thanks everyone for joining the session. It was, super duper great interacting with you all. And I hope that you have got, something out of this session. And we are looking forward to see you in our subsequent sessions as well. And